let's graph this system of nonlinear inequalities, and what that means is that means we want to graph the solution region for these nonlinear inequalities. Now notice the second graph, if I use this as an equality, it is a hyperbola. So I've already graphed the hyperbola, and now we need to decide where to shade. If you try the test point, say 3, 0, and remember then you let x be 3, so 3 squared is 9 over 4, and let y be 0. So the question is that true or false? Well, that's a true statement, and so that means that I shade within and again within, because of course I'll get the same thing if I let x be -3 and y be 0. So this is simply the graph of the second nonlinear inequality in my system. Now let's look at the first nonlinear inequality in our system, and to see the shape of the boundary line, remember we look at the equation. What is the graph of x squared plus y squared is equal to 1? Remember, that's a circle with center 0, 0, radius square root of 1 or 1. So I will also, by the way, sketch my circle in with dashed lines or dash segments because of the strictly greater than. So here I have, use your imagination, and here I have a circle, and now I shade within the circle, inside the circle, or outside the circle. Well, let's use 0, 0 as our test point. If x is 0 and y is 0, is 0 greater than 1? The answer is no, so the graph of our first nonlinear inequality is this dashed boundary line, and then you shade everything outside of that circle. Now I want you to think about this because I don't want to shade all of this, or I think it's going to get too messy. But where is the intersection then of the two graphs? If this graph is this dashed circle and then shaded all outside, and then I'm showing the graph of the other one, where is the intersection? Can you see that this is in fact then the intersection region, which means all ordered pairs in this region or in this region not only satisfy this inequality but also this inequality, so we have then the solution region.